Welcome to qnawire.
We're going to have 2-point particles, Q1 and Q2, which is going to have a charge of minus 30 nanocoulombs, and these are going to be placed on the x-axis 20 centimeters apart. So let's draw the situation. Q1, a very big space, Q2, and then we're told that a third particle with charge of 20 nanocoulombs is going to be put in the x-axis halfway between the first two particles. So let's put this guy in red. Notice that the charges here is minus 30 and minus 30. I'm going to omit the values for the constants. And what we want to know is what is the net force acting on Q3. So to do that, we know that Q2 is going to attract Q3 because they have different signs. So we can write down the force of Q2 on Q3. This guy is going to be Q3. And we can also write down the force of Q1 on Q3. That is going to have the same magnitude but going onto the opposite direction. In this case, the distance in between Q3 and Q2 and Q1 and Q3 is going to be the same. It's going to be 10 centimeters. Thus, the net force on Q3 needs to be equal to 0. Just to have this as a demonstration, remember that the magnitude of the force is going to be equal to K, Q, in this case. Let's put first force of Q1 on Q3. It would be Q1 times Q3 in absolute value divided by R squared. And also the magnitude of the force of Q2 on Q3. It would be K times the absolute value, Q2 times Q3 divided by R squared. In this case, Q1 and Q2 have the same value, so we can get rid of the subscript here. And we're only going to get the same magnitudes because the distances are going to be the same. Since the magnitudes are the same and the directions are opposite to each other, the vectors are going to cancel out. Over here, let me just complete the magnitude of the force of Q1 on Q3, just to differentiate both of them. And these are going to be vectors. So directions are opposite, magnitudes are going to be the same. So the net force is equal to 0.